All right, I'm having a little trouble with my camera, so I'm going to check every once in a while and make sure it's still recording. Today we're going to do section 13.1, Intro to Trigonometry. Trigonometry is a math study that compares angles and sides on a right triangle. So let's say I have a right triangle, and let's say I know that this side is 3, this is 4, and this is 5. And I have angle A, angle B, and angle C. Well, there are 6 trigonometric functions based on a right triangle. Those of you that have me for Algebra 1, this should continue to be familiar to you. Okay, the sine function, which is sin, and let's say I'm standing here at angle A, and it really depends on where you're standing as to what your answer is going to be. So the sine of angle A, abbreviation, is always opposite over hypotenuse. Okay, so if I'm standing here, the opposite side has a measure of 4, the hypotenuse has a measure of 5. So the sine of angle A is 4 over 5. Okay, the next one is cosine, and it's COS. And cosine is adjacent over hypotenuse. You guys remember the hypotenuse is always the side opposite the right angle. So the hypotenuse is not going to change depending on where you're standing. So I'm standing here. Adjacent is 3, hypotenuse is 5. So 3 over 5. Then I have the tangent. Abbreviation is TAN. You've seen these on your calculator. So the tangent of angle A is opposite over adjacent. So it's 4 over 3. All right, then there's 3 more that we did not cover in Algebra 1. And the first one is going to be, and I'll have to write it over here, your cosecant. Abbreviation is CSC. So the cosecant of angle A is the opposite or the inverse of this. So it's hypotenuse over opposite, or in this situation, it's 5 over 4. If this is 4 over 5, then the cosecant is 5 over 4. Then I have the secant. Abbreviation is SEC. So the secant of angle A is the opposite of the cosine. So it's hypotenuse over adjacent, or 5 over 3 in this particular circumstance. And then I have the cotangent, which abbreviation is COT, and it's the inverse of the tangent. So it's adjacent over opposite, or 3 over 4. All right, let me make sure it's still recording. All right, we're still good. All right, now there's a way to remember these, and basically you remember these first 3, and it's by the abbreviation SOCA TOA. When your toe is hurt, you SOCA the TOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Then these 3 are the reverse of these. Now it's easy to remember that cotangent goes with tangent, but I want you to remember Santa Claus for the other ones. Cosecant goes with sine, SC. Secant goes with cosine, SC. The S's do not go together and the C's do not go together. All right, so that's your intro. You must memorize this. If you don't have these memorized, this is going to be a really hard chapter for you. All right, so let's work our way through one. Let's say I have this triangle. And I know that this is 12 and this is 5. And let's say I want to know the 6 trigonometric functions of angle B. Okay, so I want the sine of angle B, the cosine of angle B, the tangent of angle B, then the cosecant of angle B, the secant of angle B, and the cotangent of angle B. Oh, I switched it to A, didn't I? All right, now you'll notice right here at the beginning though, I am missing the measure of the hypotenuse. So to find the hypotenuse, I'm going to use Pythagorean theorem on this. So 12 squared plus 5 squared equals c squared. Remember, this is little a across from angle A, this is little b across from angle B, and this would be c across from angle C. So this is going to be 169 is equal to c squared, or c is equal to 13. Okay, now I've got what I need. So if I'm saying the sine of angle B, I'm going to stand there. So I'm standing at angle B. The sine is opposite over hypotenuse, or 12 over 13. The cosecant is the reverse of this, so it's 13 over 12. The cosine is adjacent over hypotenuse, or 5 over 13. The secant is going to be 13 over 5. The tangent is opposite over adjacent. I'm standing right here, so this is the opposite. This is adjacent. Adjacent means right next to it. So it's 12 over 5, or when I reverse it, it's 5 over 12. So that's your 6 trigonometric functions based on that triangle. Sometimes you have square roots, and square roots present a little bit of different problem because remember, you cannot have the square roots on the bottom. So let's say, let's do red. So you have this triangle, and you have the square root, or you have, this is 3, S, R, and T, 6, and 3 on the square root of 5. Okay, so they give you that, and let's say they go, give me the 6 trigonometric functions of angle T. So the sine of angle T. Remember, sine is opposite over hypotenuse, so it's 3 over 3 on the square root of 5. But I have a square root on the bottom, which I can't have, so I have to rationalize the bottom. So I have 3 on the square root of 5 over 15. Reduce that down to 1 over 5. So the square root of 5 over 5. Then I have my cosine of angle T. Okay, you got to put the angle there or you don't know where you're standing on the circle or on the triangle. So the cosine is going to be adjacent over hypotenuse, or 6, and then over 3 on the square root of 5. Again, I have to rationalize, so I'm going to multiply the top and the bottom by 5. So it gives me 6 on the square root of 15, or 5, over 15. I'm going to divide the top and the bottom by 3, so I have 2 over 5. 2 on the square root of 5 over 5. Then your tangent of angle T is opposite over adjacent, or 3 over 6, which is 1 over 2. Then I'm going to do my other 3. So I've got my cosecant of angle T, which is the inverse of your sine. Well, I don't want to inverse here because it's going to put a square root on the bottom. So I'm going to come back to this spot right there before I rationalize the denominator, and I'm going to flip that. 3 on the square root of 5 over 3. The 3's cancel out. I get the square root of 5. The secant of angle T. I'm going to flip it right here. So I have 3 on the square root of 5 over 6, or the square root of 5 over 2. And then the cotangent of angle T, I'm going to flip right there, and I'm going to get a 2. And so that would be your 6 trigonometric functions based on that triangle. All right, sometimes they don't give you the whole thing out, and they don't want you to find the 6 trigonometric figures. So they might just say, erase that. Let's say they give you this triangle. and they say, find the tangent of A when the cosine of A is equal to 2 over 3. Now, I'm not trying to find everything. I'm just trying to find the tangent of angle A. So I'm right here. The tangent is opposite over adjacent. So it's simply the square root of 5 over 2. And so they're not asking you for everything. They're just asking you for one. All right. There are times when you use this type of information to find like what the angle of A is. Okay? And in order to do that, you're going to have to use what we call an inverse function. So let's say I want to know what the measurement of that angle is. So what I have is I have the angle A is the square root of 5 over 2. Well, in order to find what angle A is, I'm going to have to take the inverse tangent of the square root of 5 over 2. And if you plug that into your calculator, let's get the answer there. The inverse tangent is your second, then your tangent button, and then you're going to put that in there. The square root of 5 divided by 2, and then you're going to have enter, you're going to press enter. So second tangent, square root of 5 divided by 2, and you should get rounded to 48 degrees. If you don't get 48 degrees, you might want to go back in your mode setting and make sure it's set for degrees and not radians. So I find out that that's 48 degrees. Well, I could also find this other angle up here by knowing that the angles added together have to equal 180. So angle B would equal 180 minus 48 minus 90, which would give me 42 degrees. Okay? Now, sometimes what they do is they might even just give you, they don't even give you a triangle, but they give you a value. Let's say they tell you this. The sine of x is equal to 0.7590. And they're wanting you to find the x. Well, that x is an angle measurement. So if I'm looking for an angle, I'm always going to have to use the inverse. In this case, it's going to be the inverse sine. So x is going to equal the inverse sine of 0.7590. If I do that out on my calculator correctly, I should find a rounded off degree of 49 degrees. Okay, so you might have some problems that are like that. That's just calculator use. Then, sometimes they use all this to ask you to solve for missing things in a triangle. So let's say they give you this triangle. They go, this is B, this is C, and this is A. And they tell me 12, no, actually they tell me this is 12 and this is 9. And they want to find the missing parts. Well, I'm looking for little c, I'm looking for angle B, and I'm looking for angle A. Well, I can find little c by using Pythagorean theorem. Remember, side opposite angle C is little c. So 9 squared plus 12 squared. And that's going to give me, I think it's 225, but we'll see. Let me check the video again. Still recording, we're in good shape. All right, so that's going to give me 225, which is c squared, or the square root of it is 15. All right, so let's say I want to find, so this is 15. Let's say I want to find angle B. So let's say I'm standing right there, and I can choose any of the trig functions I want to use, sine, cosine, or tangent. Let's say I decide I want to use the tangent. Okay, it's completely up to me. The tangent of angle B is opposite over hypotenuse. So I know that if I take the tangent of whatever angle that is, I'm going to get 9 over 12. Remember I said if you're trying to find an angle measurement, you're going to use inverse. So B is equal to the inverse tangent of 9 over 12. When you do that, you find that angle B is 37 degrees. Now, in order to find A, you could just take 180 minus 90 minus 37, and you're going to get an answer of 53. So now you've done the missing parts of this triangle. All right. Sometimes they don't give you a triangle and you have to draw your own triangle. So let's say they go, well, find the missing parts if little a equals 5, little b equals 4, and little c equals the square root of 41. Well, I suggest you just draw your triangle. You know that that's C, we can call that A, we can call that B. Little a is across from angle A, little b is across from angle B, and little c is across from angle C. All right, let's say we want to find angle A and angle B. Okay, we can find angle A if I'm standing right there. Again, if I want to use tangent so I don't have to deal with the square root, I have the tangent of angle A is equal to opposite over adjacent. I'm trying to find an angle measurement, so you know I'm going to use inverse. So the inverse tangent, which is second and then the tangent button, of 5 divided by 4 is going to give me the measurement of angle A, and I'm going to get 51 degrees. So that's going to give me that. Then to get B, I have 180 minus 51 degrees minus 90 degrees, which is going to give me 39 degrees. Now you have two things going on in all these problems. You have angle measurements and you have side measurements. So make sure that you're keeping them straight. All right. Let's say this is the last one we're going to do, and then I'm going to give you your homework. We'll leave this up here, but we'll change our measurements. Let's say on this one, all they give me is that angle A is 60 and little b is 8. Okay, so I'm going to go ahead and fill it in. I would always draw your triangle. Angle A is 60 right here. My missing parts are angle B, and I guess technically you could say angle C, but I already know that that's 90 degrees. Little a and little c. All right, so I can easily find B. B is going to be 180 minus 60 minus 90, which gives me a value of 30 degrees. So I know that angle B is 30 degrees. Well, now I'm going to use trig to find A and C. So I don't know my hypotenuse. I do know my adjacent, so maybe I want to use tangent. Okay, it's up to you which one you use. Understand if you use the tangent of 60, that means you're standing right there. So the tangent of 60 is opposite, which is little a, over adjacent, which is 8. So to find little a, I'm going to multiply both sides by 8. So I'm going to go 8 times the tangent of 60 is going to give me little a, and it should give me 13.9. Okay, so this is going to give me 13.9. Now I have a choice. I can continue to use trig, or I can use Pythagorean theorem because I already have two sides of the right triangle. So I have 8 squared plus 13.9 squared is going to give me c squared. When I do that, let's see, I get, let's do this out, 64 plus 13.9 squared, that's going to give me 257.21 is c squared, and then when I take the square root of it, it's going to give me approximately 16. So I find that A is 13.9 and C is 16. All right, I'm going to give you your homework. If you get stuck on any problem and you feel like you're not doing it right, if you want to text me that problem and let me help you through that problem so then you can do the rest of your homework. I know that this is new for some of you, so we'll do what we need to do to get through it. Your homework is page 778, 16 through 44 even.